Hello, I am coming to you today with a few examples for optimization. It's related to maximizing or minimizing a particular given function. It's coming from section 3.3, which focuses on local max and mins, absolute max and mins, and optimization for functions in applied calculus. So I am going to share my screen and jump right here into these problems. Okay, so number 14, I'm going to try to zoom in just a little bit more here. And I did go to the problem and look at what was missing here. My copies got cut off a little bit, so I did complete that sentence. But on number 14, it says a deli sells 720 sandwiches per day at a price of $6 each. Um, Assume that the deli does not want to increase its price. Excuse me. Excuse me. All right. So then on part A, it says a market survey shows that for every 10 cents in reduction in the price, 20 more sandwiches will be sold. How much should the deli charge in order to maximize revenue? So we're talking about revenue. We're talking about maximizing revenue. So that's where we're going to be looking at um, some particular revenue function and the bounds or endpoints, and perhaps also where we may have an absolute max or min, where we have a horizontal tangent, which would be solving the equation for the derivative of the revenue function. So let's first find the revenue function. Let's see how we will get that. Okay. Now they tell us about the price, and we're talking about how many sold. So in this case, we're not necessarily dealing with a profit and cost function to get the revenue. Instead, we're going to use a price function and the quantity or demand. So revenue is price times quantity or demand, okay, in this case. Now, we are told that a deli sells 720 sandwiches per day at $6 each. Okay. Then on part A specifically, so let me kind of just jot that down. Price to start with, the price is $6 when quantity sold is 720. So I'm kind of just letting that hang out for a little bit because I will write new equations, or I will write equations for price and quantity kind of based upon these original amounts. Okay. Now they tell us on part A that a market survey shows that for every 10 cents in reduction in the price, 20 more sandwiches will be sold. So let's start off with let X equal the number of 10-cent reductions. Okay, so as we give more and more reductions in the price, as X increases, we want to see how we can adjust the price and quantity. Okay, so let X be the number of 10-cent reductions. Let's start there. So what happens when the price changes? Well, we're told for every 10 cents in decrease, for every 10-cent decrease, 20 more, I'm going to underline more because that's going to be plus, okay? 20 more sandwiches or so. So if we start off with the quantity of 720, so beginning with 720, 720, make that a 2 there. So beginning with 720, we're told that we're going to get as X increases, as the number of as the number of reductions increases, 20 more sandwiches will be sold. So that means our new equation for this particular context, for this particular situation, and this says for every 10-cent decrease, 20 more sandwiches or so. So beginning with 720, we say plus 20 times X. So as X increases, as the number of reductions increases, 20 more sandwiches or so. Okay? So 20 more, as X increases, more and more will be added to that 720. Okay? So that would be our price, our new price equation. Based upon this context. 720, I'm going to rewrite it, plus 20x. Okay? Now, I'm sorry, that would be our new quantity equation. I'm so sorry. Quantity. 720 is quantity. So our new quantity equation. Okay, 720 plus 20x. Because remember, we're trying to get a revenue equation, okay, for part A. So we're going to make these modifications on the original price of $6 and the original quantity of 720, okay, as these 10-cent reductions increase. So we've got a new quantity equation. Now let's see how we'll kind of work about with the price. So we're talking about X increase as X increases, which is the number of reductions, then we're saying that 720 plus 20X is the number of sandwiches sold at 10-cent reductions X. Okay. Then our new price, therefore, in addition to that 10-cent in reduction, our new price, so we're talking about reducing the price, 6 minus 0.10x. So 10-cent reductions will be, as we increase more and more of these reductions, we'll be taking away from that original price of $6. So now we have an updated new price equation related to this situation for part A and a new quantity equation. So our revenue equation, therefore, price times quantity or quantity times price, doesn't matter the order. 720 plus 20x times 6 minus 0.10x. Because x represents the number of reductions and they're reducing every 10 cents. That's the rate. Okay. So let's FOIL this out basically. We're going to have to multiply it out. So 720 times 6. Sorry about that. 720 times 6. First times first. We get 4320. Okay, first times first. Then we got our outer and our inner. So I'm going to go outer. This will be 72, I believe, because it's 720 times 0.10. 72 x. And then the inner. So that was the outer. Now the inner. 20 times 6, that's 120. So that is, oh, and this should have been minus. That outer term is minus. I'm going to put a little minus there because this is negative and this is positive. So minus. And then the inner, that's a positive 120x. So those are going to come together anyway. And then the last times the last, we have 20 times 0.10. So we have a minus, because that is minus, 2x squared, because they both had an x. All right, and then negative 72 and a positive 120 gives us 48. So we got 4320 plus 48x minus 2x squared equals 0, or equals, I shouldn't say equals yet. I shouldn't say that just yet. It's our revenue function, okay? All right. Now that we've got our revenue function, we are talking about um, price, money. So we want to ensure that our functions understand, or that we keep them positive real world. So first thing, we definitely want to ensure that X is positive. So we make sure that we're not talking about anything below 0. So X is greater than or equal to 0. And also you want to ensure that the price is greater than or equal to 0. And even the quantity sold, it should be greater than or equal to 0. So let's do all of these and let's see what our bounds end up being. Okay, so we do X because our equations are functions of X. Our functions or our equations, our revenue equation is a function of X. So that we have to ensure we're talking where X is positive. Price needs to be positive. Quantity needs to be positive because we're talking about real world application. So our price function was, so let me kind of start there. So I'll just rewrite the X because that's kind of understood. So 0 will be our minimum for sure. The price function is 6 minus 0.10x, and we want to ensure that that's greater than or equal to 0. So when I solve this, I'm going to keep the 6 over on this side. I'm going to move the 0.10 to the right side, making it positive, and then I'll divide by 0.10. And so x has to be less than or equal to 60 there. And then I'm going to do one more. I'm going to do the quantity. And it may be where the quantity value is less than that. So my end point, my final end point might end up being 60, or we'll see how big or small this next one is. So the quantity function, that was 720 plus 20x is greater than or equal to 0. So this one I think is the one that we end up tossing out because it ends up being negative. And of course, we're talking about real world, so we can't have a negative range or value for X for our domain. So if I was to take the 720 to the other side, or even move the X to the other side, let's say we do that. So that would be a negative 20x. Either one. I'll move that one though, since I already did. And then I'll end up dividing by negative 20, and that's going to be pretty much understood that we want it to be greater than a negative. So I think that's why you're going to, toss this one. So right now, when I divide by that negative, my inequality flips. So this ends up being x is less than or equal to, I'm sorry, it already was less than. It ends up being x is greater than or equal to, and this is a negative 36. So quite naturally, we want it to be greater than a negative. We've already got our lower bound of 0. 0 is bigger than that, so we stay with the 0. So in order for it to satisfy this, it has to be at least 0. It can't be at least 36. So we toss that one. So our ends, our bound is 0 to 60 is what we're working with there for our revenue. And we could also have an absolute max or min at a horizontal tangent. So where the derivative is equal to 0. So it could be at the endpoints, or it could be where the derivative of the revenue function is equal to 0, where you have a horizontal tangent. So I'm taking the derivative, I'm finding the derivative. That's going to be 4320 drops off. Then I'll take the derivative of 48x, that's 48. And then this 2 will come down and make that a minus 4x. Okay, so we've got 48 minus 4x equals 0, because we're going to solve that now. Let's take the 4x over to the other side. Divide by 4, x equals 12. Okay, so we now have our ends. Okay, our interval. We're talking about revenue being within this particular interval, 0 to 60. And then we also had within that interval, we had a partition or critical number at x equals 12. So with that, we're going to find where the max value of the revenue occurs. The max, scoot that over a bit. The max revenue, I think I'll just get me a new clean sheet of paper here, and then I'll move that out the way in just a second. So the max value, I'm trying to maximize revenue. The max value of the revenue occurs at an endpoint or when the derivative is equal to 0, which is, of course, the first derivative test, horizontal tangent. Okay, where the horizontal tangent of the revenue function is 0, or where we have a horizontal tangent. So I'm going to create a little sign chart here. X could be 0, 12, or 60. And then I want to see what R will be. So when I plug in 0 into the revenue function, which I'm going to kind of slide back down here a little bit. There's the revenue function. When I plug in 0, I have 0 here and I have 0 here. So I end up with just 4320. Okay. When I plug in 12, let's see what we get. 4320 plus 48 times 12 minus 2 times 4, nope, 2 times 12 of 12 squared. So we get 4608. And then lastly, when I plug in 60, 4320 plus 48 times 60 minus 2 times 60 squared, we get 0 there. So the max occurs, the max revenue occurs at x equals 12. So the deli should charge the following price. P equals 6 minus 0.1 x. So 6 minus 0.1 times 12, which is $4.80. Okay. So looking back, let's make sure we answer the question completely here. On part A, it says the deli. So the deli should charge $4.80 for part A. Okay. Part B, a different market survey shows that for every 20-cent reduction in the original price of $6, 5 more sandwiches will be sold. So for every increase in reduction, and remember, X represents the number of deductions. So as the number of deductions increases, 5 more sandwiches will be sold. So for part B, it says, now how much should the deli charge in order to maximize revenue? All right, so let's go back and set up our new quantity equation and our new price equation. So we're still going to let X equal the number of reductions. They're, 20-cent reductions, but X is going to equal the number of reductions. So the quantity sold at X reductions is 720 plus 5X, because we're saying that 5 more sandwiches will be sold for every, as X increases, 5 more sandwiches will be sold. So as X continues to increase, they'll sell 5 more groups of 5 more sandwiches. Okay? So that's our new quantity equation, if you want to call it that. So for every 20-cent reductions, 5 more will be sold. Okay? Then our new price equation, then, so this is the quantity equation. Our new price equation will be 6 minus this new 20-cent reduction. So as X increases, as the number of reductions increase, 20 cents gets taken away or deducted or subtracted from this original cost. So the more X's are sold, the more deductions will be made from that price. So our revenue function is going to be the price times the quantity, or the quantity times the price, whichever way you want to look at it. 720 plus 5X times 6 minus 0.20X. Okay, so I'll go through using the FOIL method here. 720 times 6, 4320, my outer and my inner. My outer terms, we get 720 times 0.2, we get 144, and that's going to be a minus 144X. Our inner, we get a 30X. And then our last times our last, 5 times 0.20, we get 1X squared, and it's going to be minus. So that 144 and that 30 will combine. So negative 144 plus 30 gives us a minus 114. So we got 4320 minus 114X minus X squared. There's our revenue. I'm just call it R of X. Okay. Kind of box this off for a minute, because I will use that. I will take the derivative in just a second. Now, let's get our endpoints. Let's think about this. So we know that X must be non-negative. So that we know. Our function R, our revenue function, is a function of X. X has to be positive. Okay. So that's one condition. Then we also need our price to be non-negative. So 6 minus 0.20X must be greater than or equal to 0. And then technically quantity also would be non-negative. But when we looked at that before, remember we ended up with a negative and we dropped that off because the smallest value has to be 0. But if you want to, you can go ahead and put that as well. And then we'll end up just kind of tossing it out. So all three must be non-negative. X must be non-negative because our revenue is a function of X. Our price function must be non-negative, and our quantity function must be non-negative. And again, we'll end up dropping this one off because when we solve it, we end up with a negative. Because when you take 720 over, it's negative 720, and then you divide by 5, you end up with a negative. Okay. So here are the two that we'll focus on. So this one is already solved for X, so let's solve this one. So I'm going to say plus 0.2. I have 6 over here, and on this side, I have 0.20x, and then I'll divide by 0.20, and that gives me 6 divided by 0.2. I get 30. So 30 is greater than or equal to x, or in other words, x has to be less than or equal to 30. So x has to be less than or equal to 30, greater than or equal to 0. These are our bounds. Okay. So in addition to checking these endpoints for absolute max, or for our maximization of the revenue function, we also may consider where we have the derivative equal to 0. So let's find the derivative. The derivative of the revenue function, this will be a minus 114, and this one will be a minus 2x. Okay? So then we will place that equal to 0 to solve. I'm going to take the 2x over here. And then I am going to divide by 2, but negative 114 divided by 2 gives me a negative 57. And because this is negative, we're going to toss this out. It's not in the domain. So we don't have to worry about checking it. Remember, our domain is non-negative. So this is not in our domain, so we don't have to worry about checking that. We just need to check for the endpoints then, 0 and 30. So our revenue function evaluated at 0 gives us 4320, because that becomes 0, that becomes 0. So at 0, our revenue function is 4320. At x equals 30, we have 4320 minus 114 times 30 minus 30 squared. And we get 0 there. So the maximum revenue occurs at x equals 0. So the price is 6 when you evaluate. So max revenue occurs at x equals 6. So the price is 6 minus 0.20 times 0, because we're letting x be 0. I'm sorry, I said x6, it's at 0. The max revenue occurs when x is 0, and we evaluate the price function at 0. And so we end up with just 6. So for part B, here's that answer there where we got it. Again, when we evaluated the revenue, when we took the derivative of the revenue function, we then solved it for x by placing that equation, the derivative equal to 0. It was not in the domain, so we tossed it out. Therefore, we only had to evaluate the revenue function at the endpoints, and the largest value was at 0, so that's where the max revenue is. It occurs when x is 0, and so we then, to get the price, at maximum revenue, to get the price, we evaluate the price function at that value for x. So the deli should now charge, for number 14, that answer is 6. Okay, that answer is 6. All right, let's look at number 15. Let's look at one more of these here. So on this one, it says a car rental agency rents 220 cars per day at a rate of $40 per day. For each $1 increase in rate, 5 fewer cars are rented. I'm thinking it's meaning at what income should the cars be rented to produce the max income? At what price, perhaps? I believe it got cut off. Well, I know it got cut off. I believe that's supposed to say price. At what price should the cars be rented to produce the max income? Okay. And then it says, what is the max income on number 15? All right. So with this one, we're looking for max income, maximizing income. So let's say income, which is same thing as revenue, essentially, is price times quantity. Okay. So price per day times the number of cars rented out. Price per day times the number of cars rented each day. Okay. So let's let X equal the number of increases in rate. So let X, this statement right here says for each $1 increase in rate, 5 fewer cars are rented. So let's let X equal the number of increases in rate, number of rate increases. Let's do that. Number of rate increases. Okay. So what I want to do is find a new a new price equation, given that the price per day is 40 to start with, and then it says for each $1 increase in rate, 5 fewer cars are rented. So our new price equation, it will start off with the 40, but then we're increasing that by $1 for every increase in X. So plus 1X. For every increase in X, the price is $1 more. Okay. Then we're talking about quantity also. For every increase in X, 5 fewer cars are rented out. Now we're told, just like we were given a base price here of 40, we're given a base rental amount here of 220. It says a car rental agency rents 220 cars per day at this rate. So our quantity equation will start off with 220 as the base, and then 5 fewer cars. So we're reducing this amount as X increases. So as X increases, as the number of rate increases as the number of rates rises, we will get 5 fewer cars rented out. So 220 minus 5 times X. Okay. So income or revenue, same thing. Income is 40 plus 1X times the quantity, which is 220 minus 5X. So we're going to FOIL that out, multiply that out to get a nice income function. So FOILing, let's say 40 times 220, we get 8,800. Our outer function, 40 times 5, and it's going to be minus here. We get a minus 200X. Our inner, we get a plus 220X. And then our last times our last, we get a minus 5X squared. All right, and then we're going to combine these two middle terms. And I'm just going to call this function I, okay, for short. So we've got 8,800 and then 220 or positive 220 minus 200. That's just 20. and then minus 5x squared. Okay, so we got our income function. Now, let's think about this real world situation because we have to bound it, okay? We know that x must be non-negative because we're talking about x representing real world situation price increases or rate increases. So x must be greater than or equal to 0. That we know for sure. A couple other stipulations. 40, the price equation, the 40 plus 1x, it must also be non-negative. So it must be greater than or equal to 0. And then also, even technically, the quantity equation must be non-negative. So 220 minus 5x must be non-negative. So I'm going to solve each of these and see what I'm given. This one's done. Here, I'm going to take the x to the other side, it looks like. That's going to make this a minus x. If I take it, let's take 40 over. Let's go with that. Okay. So x has to be greater than or equal to negative 40. Well, we know that it has to be greater than a negative number. In fact, it must be at least 0. So we're going to toss that. Okay. So this last one, let's take the 5x to the other side. Bringing it over to the right side makes it positive, and then let's divide by 5. So x is greater than or equal to 220 divided by 5. We get 44. So x must be less than or equal to 44. X must be greater than 0. So x in the middle between 44 and 0. Okay. All right. So here are our endpoints. We will evaluate our income function at these endpoints to see what our maximum income will be at which value of x. In addition to the endpoints, it could also be where we have a horizontal tangent. So that's where I have to find I prime. That's where I take the derivative of the income function. So when I take the derivative, 8,800 drops off. The derivative of 20x becomes 20. And then the derivative of this negative 5x squared comes down as a minus 10x. Okay? I'll solve this for x. Excuse me. So I've got 20 minus 10x equals 0. We're going to take 10x to the other side now, divide by 10, and x is equal to 2. Okay? Now, with that being done, we can set up a little sign chart or a little table, whichever you want to call it. So x can be 0, 44, or 2. And then what we're going to do is evaluate the income function at these values to figure out where our max is, because we're trying to maximize income. So it will either be at an endpoint or where we have a horizontal tangent for the function. So in other words, where the derivative equals 0. And the derivative was equal to 0 when x was equal to 2. So when I evaluate the function at 0, here's my function. 0, 0, so that's going to just be 8,800 when x is 0. When I evaluate it at 2, let's see what we get. 8,800 plus 20 times 2 minus 5 times 2 squared. We get 8,820. So it looks like so far that one's the biggest. And then let's try evaluating it at 40. 8,800 plus 20 times 40 minus 5 times, I'm sorry, that should be 44. 44. And then 44 here. Okay, there we go. So 8,800 plus 20 times 44 minus 5 times 44 squared, we get 0. Excuse me. So our max income, our max income of 8,820 occurs when x is equal to 2. Excuse me. Okay. So we've got the max income earned when x is equal to 2. We want the price for every rental at that particular income. So at x equals 2. So the price at x equals 2, price function is 40 plus 1x, which is 40 plus 1 times 2, which is 42. So bringing this back down here, let me zoom out a little bit. I'm still not able to show it all, but I'll just, since we've looked at this, I'll just kind of cover that up for a second and put the answer right here. So the rental agency will earn a maximum income of 8,820 when it charges $42 per day. And the price is 42 per day. So we found the max income, which occurred when x was equal to 2. And then the price when x is 2, the price is 42. Okay. And now I'll bring that back down some. All right. And that wraps up module 3. And it also wraps up our first half of the course, even though the second part is really more condensed down to just one module. We've got 2 branches of calculus, differentiation and integration. The first 3 modules really focused on differentiation. It's probably the most important branch, and integration just kind of works in reverse. So we'll start with integration in module 4 next week. So I will make, just be aware of my emails. I'll set the due date for module 3 right before we begin module 4. Hope you all have a wonderful weekend.